Good morning. In the previous lecture, we've seen that what is the definition of characteristic value. Okay. So throughout this discussion, the T will be regarded as the linear operator on finite dimensional vector space V over F. Okay. So what is the definition of linear characteristic values? Let T be a linear operator on a finite dimensional vector space. Suppose the dimension of that vector space n over the field F, then a scalar C belongs to F is called characteristic value of T. If there exists a non-zero vector alpha belongs to V such that T of alpha is equal to C alpha. Okay, then this C is called as characteristic value of T, and this alpha, that is non-zero vector alpha, we call as a characteristic vector corresponding to the characteristic value C. Okay, so look at here. If T is the matrix of matter A is the matrix of T with respect to the ordered basis, standard ordered basis beta. Then, okay, suppose the find out the roots of that characteristic polynomial is nothing but characteristic values. Okay, if the dimension of vector space is 3, then we get the matrix of order 3 cross 3. Okay, then how many roots are there for characteristic polynomial? 3 roots, and that 3 roots are nothing but our characteristic values. Okay, so this we see in the previous lecture. So today we will discuss some more concepts. Okay, wait a minute. The characteristic values is also called as eigenvalues, spectral values. Okay, so characteristic values are sometimes or are also called as proper values. Okay, proper or eigenvalue or spectral value. Okay, spectral or latent values. Okay, all the words have the same meaning. The characteristic values is also called as proper values, eigenvalues, spectral values, or latent roots. Okay, and similarly, the characteristic vector is also called as characteristic vector are called proper vectors. Okay, proper vectors or eigenvectors or spectral vector. Okay, and the set of all the characteristic values of T is called spectrum of T. Okay, what is the next definition? The next remark. The set of all characteristic values, okay, of the transformation T is called spectrum of T. Spectrum of capital T. Okay, any doubt up to here? Okay. And the next theorem is
No, sir.
if alpha, okay, if alpha is the characteristic vector of T, is characteristic vector of capital T corresponding to the characteristic value C. Okay, then K into alpha is a characteristic vector of capital T. Okay, is capital T corresponding to the same characteristic value capital C. Okay, where capital K, okay, is any non-zero scalar. Non-zero scalar. Okay, this is the theorem. If alpha is the characteristic vector of T, then K of alpha is also characteristic vector of T, corresponding to the same characteristic value C, where K is any non-zero scalar. Okay, now look at the proof. If alpha is the characteristic vector, okay, if alpha is characteristic vector, okay, of linear operator P, of linear operator capital T, corresponding to the characteristic value C. Okay, then by the definition, we have T of alpha is equal to C into alpha. Okay, give it as an equation number 1. Okay, now let K be any non-zero scalar. Okay, let K be any non-zero scalar belongs to field F. Now consider, we have to prove that K into alpha is also characteristic vector corresponding to the characteristic value C. Okay, that is, we have to show that T of K alpha is equal to C into K alpha. Is it correct? This means that K alpha is the characteristic vector.
Yes, sir.
Okay, now take K be the any non-zero scalar. Now consider T of K into alpha. Okay, but T is linear operator and K is the scalar that belongs to F. By the definition of linearity, we have this is K into T of alpha. Why? Because T is linear operator. Okay, so this is equal to K into what is T of alpha is equal to C into, okay, where
C
K
into
and
alpha.
C belongs to what? F. F is the field. Okay, that means F is the commutative. So this is equal to associative first of all. K into C into alpha. Okay, F is associated. Okay, now C into this one K into alpha. F is what? Commutative. Okay, because F is the field. This is equal to C into K into alpha. Okay, so we get T of K into alpha is equal to C into K of alpha, C into K alpha. So this implies, this shows that, this shows that K into alpha is a characteristic vector of capital D corresponding to the characteristic value C. Okay, corresponding to the characteristic value C. Any doubt? Okay, बाकीच्यांना काही डाऊट आहेत का?
No, sir.
How many students are there? 21. What is the theorem? If alpha is the characteristic vector of T corresponding to the characteristic value C, then K alpha is a characteristic vector of T corresponding to the same characteristic value C, where K is any non-zero scalar. Okay, so one note is there. Look at that note. Okay, what is that note? corresponding to the each characteristic value C. Okay, there may corresponds more than one characteristic vector. Okay, corresponding to each characteristic value, capital C. There may correspond more than one characteristic vectors. Okay, what is the meaning of this one? If suppose alpha 1 is the characteristic vector, okay, corresponds to C, then what we have? T of alpha is equal to C alpha. So T of alpha 1 is equal to C into alpha. For this characteristic value, we get, okay, we may correspond more than one characteristic vector. Okay, असा एक अल्फा तो एक्झिस्ट होईल जो की ही कंडिशन satisfy करेल. Okay, corresponding to each characteristic value, there may correspond more than one characteristic vector. Okay, now look at here. Alpha is the characteristic vector of T corresponding to the characteristic value C. Okay, now here we get K into alpha, this another vector. Okay, other than this alpha is also what? Characteristic vector of to the characteristic value C again. Okay. We may get one more characteristic vector. Okay. Any doubt up to here? Okay.
No, sir.
Now, suppose this is these are the some characteristic values C1, C2, C3. Okay. T is the matrix. T is the transformation. Okay. This is the matrix of T. Okay. A is the matrix of T with standard order basis beta. Okay. Suppose the order of A, matrix of A is equal to T. This one is 3 cross 3 matrix. Okay, and suppose there, how many characteristic values are there? Suppose this is C1, C2, C3. These are the three characteristic values of this matrix. That means these are the three eigenvalues, that is characteristic values of matrix transformation T. Okay, so what is the next theorem says? If suppose this alpha 1 is the characteristic value, characteristic vector of T corresponding to the characteristic value C1, then this alpha 1 is not the characteristic vector. Okay, not characteristic vector corresponding to the eigenvalue C2. Okay, जर हा अल्फा 1 कॅरेक्टरिस्टिक वेक्टर असेल करस्पॉन्डिंग टू दी C1, म्हणजेच काय? T of alpha 1 is equal to C1 into alpha 1. Okay, now T of alpha 1 is not equal to C2 into alpha 1. Okay, the next theorem says that if alpha is the characteristic vector of T, then alpha cannot corresponding to more than one characteristic value of T. Okay, if alpha 1 is the characteristic vector of T corresponding to the C1, हा फक्त C1 लाच correspond असेल, then this alpha 1 is not the characteristic vector corresponding to this C2 or C3. Okay, समजते का काय म्हणतोय मी?
Yes, sir.
Yes, sir.
तर हा अल्फा 1 जर कॅरेक्टरिस्टिक वेक्टर असेल करस्पॉन्डिंग टू C1, तर हा अल्फा 1 C2 किंवा C3 ह्याचा कॅरेक्टरिस्टिक वेक्टर नसेल करस्पॉन्डिंग टू धिस C2 आणि C3. ओके, म्हणजे ही कंडिशन तो सॅटिस्फाय नाही करणार. ओके, लुक एट द थिअरम. द नेक्स्ट थिअरम सेज दॅट if alpha is the characteristic vector of capital T, then alpha cannot correspond to more than one characteristic values of T. Okay, the alpha 1 is the characteristic vector of T corresponding to the C1. Then this alpha 1 is not the characteristic vector corresponding to C2 or C3. If C1, C2, C3 are the three characteristic values of T. Okay. म्हणजे हा अल्फा 1 कुठल्या तरी एकाशीच करस्पॉन्ड असतो एक आयगेन व्हॅल्यूशी. Okay, now look at it. Suppose alpha is characteristic vector of capital T. Okay, correspond to two characteristic values. Okay, which is C1 and C2. Okay, suppose alpha is the characteristic vector of T corresponding to the characteristic values C1 and C2. Then by definition, what we have? Then by definition, we have T of alpha is equal to C1 alpha. Okay, and T of alpha is equal to what? C2 alpha. Is it correct?
Yes, sir.
So this implies C1 alpha is equal to C2 alpha. Okay, so this implies C1 alpha minus C2 alpha is equal to 0. Okay, हा तिकडे गेल्यानंतर मायनस होईल असा अर्थ नाही यायचा बरं का. अल्फा बिलॉंग्स टू कॅपिटल V. दिस इज वेक्टर स्पेस. C into C2 into alpha again belongs to V closed with respect to multiplication. Okay, closure property satisfy करते. And V is the vector space. म्हणजे ह्याच्यात काय असेल ऍडिटिव्ह आयडेंटिटी. दिस इज अबेलियन ग्रुप असतो. ओके, अबेलियन ग्रुप आहे म्हणजे काय ह्याचा ऍडिटिव्ह इनव्हर्स आहे ह्याच्यात. Okay, minus C2 alpha belongs to again V. Okay, मग दोन्हीकडे काय करतोय आपण add additive inverse of C2 alpha, then C1 alpha minus C2 alpha is equal to 0. This implies C1 minus C2 of alpha is equal to 0. याचा अर्थ आपण कॉमन काढला असं नाही. ओके, काय हा डिस्ट्रीब्युटिव्ह ओव्हर addition ना कुठली प्रॉपर्टी आहे? Distributive addition. So this implies, but alpha is what? Non-zero vector. Okay, but alpha is not equal to 0. In the definition of characteristic vector, alpha is the non-zero vector. So this implies what we have then C1 minus C2 is equal to 0. हा जर 0 नसेल तर हा 0 असेल का? क्या रीजन क्या है? C1 and 2 of alpha belongs to capital V. Okay. Correct? का असेल? हा V फील्ड असतो की C or R. हा फील्ड असतो का? Yes sir. हा फील्ड आहे.
Yes, sir.
ओके, फील्ड आहे म्हणजे काय तो इंटिग्रल डोमेन आहे. ओके, इंटिग्रल डोमेन आहे म्हणजे काय? One the product of two is equal to 0, then it implies one of them is 0. This is the reason.
Without
This
zero
implies
division.
C1 is equal to C. Okay. This shows that the characteristic vector of T correspond to exactly one characteristic value of t. Is it correct? Any doubt? So दोन व्हॅल्यू घेतले C1 आणि C2
No, sir.
तर काय येईल जर हा दोघांना करस्पॉन्ड करत असेल हा अल्फा if this characteristic value corresponds to the C1 and C2 it implies C1 must be equal to C2. That means the C1 and C2 characteristic must be same. Okay, hence alpha is the characteristic vector of T. Then alpha cannot correspond to more than one characteristic value of T. Okay, any doubt? Okay.
No, sir.
एक जे एक्झाम्पल आहेत कॅरेक्टरिस्टिक व्हॅल्यूज कसे फाइंड करायचे कॅरेक्टरिस्टिक वेक्टर कसे फाइंड करायचे ओके हे सगळे जर थेरम झाल्यानंतर बघूया ओके नाउ नेक्स्ट थेरम इज set of all characteristic vectors forms a subspace. Okay, what is the theorem? Let capital T be a linear operator. Capital T be a linear operator. Okay, on finite dimensional vector space V over F. And let capital C okay, be a characteristic value of capital T. Then we have to show that the set, which set? The set denoted by WC, that is equal to belongs to V such that T of alpha is equal to C alpha. Okay, what is the set? Set of all characteristic vector corresponding to the characteristic value C. Okay, is subspace of कोणाचा असेल सबस्पेस ऑफ व्ही ना व्हीचं कलेक्शन आहे ना व्ही मधनं आपण कलेक्ट करतोय ओके असे कलेक्शन ऑफ हा जर तुमचा जर व्ही असेल ओके हा जर WC असेल व्हॉट इज WC collection of all alpha belongs to V such that T of alpha is equal to C alpha. That means collection of all the characteristic vector of T with respect to C1 relative to the C1. Okay. Then we have to show that this WC is the subspace of V. Get the proof. Let alpha and beta belongs to WC and A belongs to F, where F be any scalar. Be any scalar. Okay. Alpha belongs to WC. This implies E of alpha is equal to CL. Beta belongs to WC. This implies T of beta is equal to C into beta. Is it correct? WC
Yes, sir.
is the subspace of V. Then we have to prove that A into alpha plus beta belongs to WC. Okay, this is the necessary condition for this subspace. That is, WC मध्ये T of A alpha plus beta is equal to C into A alpha plus beta. If this vector satisfies this condition, then A alpha plus beta belongs to WC. Okay, now consider T of A alpha plus beta. This is equal to T is linear operator. That means this is the scalar A. T of alpha plus T of beta. Why? T is linear operator on finite dimensional vector space V. So this implies A into what is T of alpha? Cn. Okay. C into alpha.
Scene
What
12.
is T beta? T of beta? C into beta. Okay, this is equal to
C beta.
C into A alpha plus beta. Okay, distributive over addition. This is distributive over addition. Okay, so this implies T of A alpha plus beta is equal to C into A alpha plus beta. This implies A alpha plus beta belongs to WC. Okay, this implies WC is equal to alpha belongs to V such that T of alpha is equal to C alpha is what? Subspace. Subspace of capital V. Okay, that is V. Any doubt? That means set of all the characteristic
No, sir.
vectors corresponding to the same characteristic value forms a subspace. Okay. Now these are nodes are there. Okay. Look at the nodes. Remarks are there. Or nodes. First one. The set WC. Okay. Is nothing but the set of all characteristic vectors, okay, of capital T corresponding to the characteristic value C or eigenvalue corresponding to the characteristic value capital C. Okay, provided V include the zero vector. Okay. In this set. What is the meaning of this one? In this set. या डेसिमल तुमचा झिरो वेक्टर आहे का? हा जर सबस्पेस असेल म्हणजे याचा झिरो वेक्टर कोण असायला हवा? हा आहे का? Zero belongs to V such that T of zero is equal to zero because T is zero. That is, we can write this T of zero is equal to zero is equal to C into zero. That means हा zero काय करतो ही condition satisfied करतो. That means zero also belongs to this W. Okay, एखादा सेट सबस्पेस आहे म्हणजे त्याच्यात झिरो वेक्टर असायलाच हवा. ओके, इटसेल्फ हा वेक्टर स्पेस. इटसेल्फ हा वेक्टर स्पेस म्हणजे आहे त्याच्यात झिरो वेक्टर असायलाच हवा. ओके, सो दॅट मीन्स the characteristic value C, zero vector is the characteristic vector. Zero vector is the only vector हा सगळ्या eigenvalue शी correspond करतो. Okay, C1, C2, C3 काही का असणार. Suppose C1, C2, C3. These are the three eigenvalues of the matrix of T. Okay, then we have T of 0 is equal to 0 because T is linear. Then we can write this T of 0 C2 into 0 or C3. Vector is the only vector according to the each and every eigenvalue, that is characteristic value. Okay, that means 0 corresponding to C1, corresponding to C2, corresponding to C3. Okay. Okay, समजा हा जर माझा सेट WC1 असेल. ओके, आणि WC2 काय असेल? Corresponding alpha belongs to V such that T of alpha is equal to C2 of alpha. How C1 alpha? Then intersection of WC1 and WC2 काय असेल? सबस्पेसचा इंटरसेक्शन काय असतं? What is the intersection of singleton zero? हा
Subspace.
only singleton वेक्टर असेल. ओके, ह्याच्यातले वेक्टर ह्याच्यात जाणार नाही कधी, आणि ह्याच्यातले वेक्टर ह्याच्यात कधी जाणार नाही. आताच काय आता alpha is the characteristic vector of E, then alpha cannot be corresponds to more than one characteristic value. म्हणजे अल्फा एक WC1 मध्ये असेल किंवा WC2 मध्ये असेल. फक्त झिरो वेक्टर सोडून सगळे. ओके, झिरो वेक्टर हा सगळे इच एंड एव्हरी सबस्पेस मध्ये असेल. Okay, and suppose this is the WC1 is equal to alpha belongs to V, such that T of alpha is equal to C1 alpha, and this one another subspace corresponding to the eigenvector eigenvalue C2. Then WCT is equal to alpha belongs to V, such that alpha T of alpha is equal to C2 alpha. Then intersection of these two subspace is equal to singleton zero only. Okay, any doubt? Okay, काही कळते का? डोक्यावरून जाते सगळं.
No, sir. Sir, T of 0 is equal to
ते
same to
सांगतोय
0 कसं घेणार आपण?
नॉन झिरो
नॉन
तर
झिरो
सगळे
वेक्टर
असणार
घ्यायचा
आहे,
ना.
पण झिरो
अल्फा
वेक्टर
इज
हा
इक्वल
असा एक ओनली वन वेक्टर आहे जो सगळ्या त्याच्यामध्ये सगळे कंडिशन सॅटिस्फाय करतो. ह्याचा अर्थ काय? WC1 इज इक्वल टू WC1 इज इक्वल टू काय? अल्फा बिलॉंग्स टू V such that T of alpha is equal to C1 alpha. ओके, राइट, C only. ओके, जो कोणी ही कंडिशन सॅटिस्फाय करेल तो या सेटमध्ये जाईल, याचा अर्थ. इज इट करेक्ट? T of 0 काय येईल?
Yes, sir.
T is the linear operator 0. C1 काय तुमचा?
जी.
C1. ओके, that is C1 into 0. मग 0 वेक्टर ह्याच्यात असेल का नाही? ऑब्वियसली असेल. कोणत्याही डिसजॉइंट सबस्पेसचा जेव्हा तुम्ही इंटरसेक्शन घेताय तेव्हा एम्प्टी सेट येत नसतो. ओके, सेटचा जेव्हा दोन डिसजॉइंट सेट असतील, काय सांगतो नाही टाकाय, दोन डिसजॉइंट सेट असतील, सेट नॉट सबस्पेस, तर त्यांचं इंटरसेक्शन एम्प्टी सेट येतो. जर सबस्पेस असतील दोन डिसजॉइंट सबस्पेस, ओके, तर त्यांचं इंटरसेक्शन ऑलवेज सिंगलटन झिरो येतो. ओके, सपोज W1 and W2 these are the two subspace of V, disjoint subspace. Then W1 intersection W2 is equal to singleton zero. कळतोय का?
Yes, sir.
फॉर एक्झाम्पल सपोज V is equal to
फाय येणार नाही का?
फाय येत नसतो. सबस्पेसचा इंटरसेक्शन डिसजॉइंट सबस्पेसचा इंटरसेक्शन ऑलवेज सिंगलटन झिरो येतो, ते सांगतोय. सपोज V is equal to R2. Okay, and suppose W1 is equal to V belongs to alpha belongs to R2 such that wait a minute, हा कसा येईल? This is W1 is equal to XY belongs to R2 such that R2 चा सबस्पेस असेल ना, X is equal to 0. ओके, म्हणजे W1 मध्ये सगळे कनेक्शन कसे असतील? सेट्स 0 1. ओके, या फॉर्म मध्ये असतात. इज इट करेक्ट? This is W. Suppose
Yes, sir.
W is equal to XY belongs to R2 such that Y is equal to 0. म्हणजे याच्यातले एलिमेंट कसे असतील? X0. ओके, ग्राफिकली जर आपण पाहिलं तर कसं दिसेल? हा R2 तुमचा. ओके, W1 is collection of all the elements belongs to R2 so that X is equal to 0. म्हणजे काय असेल? हा तुमचा W1, Y ऍक्सिस म्हणजे तुमचा W1 असेल. इज इट करेक्ट? ओके, 0 Y हा एक पॉइंट कुठे येतोय? इथे कुठेतरी असतो, इथे असेल. ओके, X0 कुठे असेल? इथे असेल. दिस इज W2. व्हॉट इज इंटरसेक्शन ऑफ दिस टू? ओके, म्हणजे आता 0. ओके, हा तुझा 0 वेक्टर आहे ना, म्हणजे हा एकटाच असा वेक्टर आहे जो ही पण कंडिशन सॅटिस्फाय करतो आणि ही पण कंडिशन सॅटिस्फाय करतो. इज इट करेक्ट? ओके, म्हणजे दोन सबस्पेसचा इंटरसेक्शन घेतल्यानंतर तो एम्प्टी येत नाही, तो ऑलवेज 0 वेक्टर देतो. ओके, 5 वेक्टर स्पेस आणि जर दोन सेट्स असतील, सपोज दिस इज ए सेट and this one is B set. Okay, these are some, suppose disjoint set. Suppose this is Q, this is Q dash international A dash. Okay, these are the two subsets of R. Then what is the intersection of these two one is empty set ना, pi set. Okay, पण सबस्पेसचा जेव्हा आपण इंटरसेक्शन घेतो तेव्हा त्यात झिरो वेक्टर ऑलवेज असतो. Hence, WC is nothing but set of all the characteristic vectors of T corresponding to the characteristic value C, provided we include the zero vector in this set. Okay. Now, what is WC? The second lemma. WC is the null space of the linear operator T minus C into R. Okay, what is WC? Look at here. What is WC? WC is equal to collection of those vectors in V such that T of alpha is equal to C into alpha. Okay, what is alpha? Alpha belongs to V. So we can write this alpha is equal to R of alpha, identity operator. Okay, so this is WC is equal to alpha belongs to V such that T of alpha is equal to C into R of alpha. Is it correct? I is identity operator. So this is WC is equal to alpha belongs to V such that this is T of alpha minus C into I of alpha. Okay, okay, that's operator. This one is also operator. This one is also operator. Is equal to what? Zero function, zero operator. This is WC. This implies WC is equal to alpha belongs to V such that T minus Ci of alpha is equal to 0. Okay. What is WC? That is what? Null space of T minus Ci. What is the null space of T? What is null space of T? By the definition, null space of T.
Alpha belongs to V such that T of alpha equal to 0.
Alpha is equal to 0. Okay. What is null space of T minus Ci? Alpha belongs to V such that instead of T, write down T minus Ci. Okay, equal to 0. Okay, that is WC is nothing but null space of T minus Ci. Okay, any doubt? Okay, now hence
No, sir.
the subspace WC of capital V is called characteristic space of characteristic value C of the linear operator T, of the linear operator capital T. Okay, it is also called the space of characteristic vector of T associated with characteristic value C. Okay, it is also called एक खूप महत्वाचे पॉइंट्स सेटला डायरेक्ट विचारतात हे सेट नाही. It is also called the space of characteristic vector. Okay, why? Because that subspace contain all the characteristic vector corresponding to the characteristic value C. Okay, that's why it is also called the character space of characteristic vector of T corresponds to or associated with characteristic value of C. Okay, any doubt up to here?
No, sir.
Okay, now one remark is there. Remark. Okay, what is that remark? If C, capital C, is the characteristic value of capital T. Okay, then if C is the characteristic value of T, if the characteristic space WC is different from zero subspace. Okay, what is the meaning of this one? म्हणजे तुमचा WC काय असेल? Not singleton zero subspace. Okay, if C is the characteristic value of T, then there always exists one non-zero vector alpha such that T of alpha is equal to CL. Okay, असा एक तरी वेक्टर एक्झिस्ट होते. ओके, हा एक एक्झिस्ट झाला तर स्केलर प्रोडक्ट पण काय असायचं? स्केलर मल्टिपल ऑफ अल्फा इज ऑल्सो कॅरेक्टरिस्टिक वेक्टर. ओके, हे पाहिलं आपण मगाशी. Okay, that's why WC is not equal to singleton zero subspace. That is characteristic space WC. याचाच अर्थ काय? Any doubt? Okay. Now, the two more
No, sir.
definitions are there: singular and non-singular transformation. Okay, एखाद्या मॅट्रिक्स आपण सिंगुलर आहे किंवा नॉन सिंगुलर आहे पाहिलं. When we say that this matrix is singular, equal to zero कधी येईल? जेव्हा
Determinant equal
त्याचा
to 0.
एखादा आयगेन व्हॅल्यू जर झिरो असेल. Okay, when we say that the transformation matrix is non-singular, म्हणजे त्याचा
When
डिटर्मिनंट
all
इक्वल टू
its
नॉन झिरो आणि
eigenvalues are
डिटर्मिनंट नॉन
non-zero.
झिरो असेल तर त्याचा काय म्हणतो आपण? इट इज इन्व्हर्टिबल. ओके, इन्व्हर्टिबल आहे म्हणजे तो कसा आहे? 1 1 आणि 1 2 आहे. तेच सगळे
Yes,
कन्सेप्ट
sir.
लागू होतात. ओके, एखादं जर ट्रान्सफॉर्मेशन जर नॉन सिंग्युलर ट्रान्सफॉर्मेशन असेल तर तो काय असेल? ट्रान्सफॉर्मेशन 1 1 आणि ऑन टू 1 1 असेल. Okay, so necessary condition for the non-singular transformation, kernel of T must be equal to singleton zero. तर kernel of T is equal to singleton zero असेल तर तो काय असतो? 1 1 ट्रान्सफॉर्मेशन. हे पाहिले BSc ला झाले ना? If kernel of T is equal to singleton zero, then
Yes, sir.
T is 1 1. Okay. Now look at the definition. The two more definitions are there: singular and non-singular. ज्या काही तुमच्या प्रॉपर्टीज टीच्या असतील त्याच प्रॉपर्टीज तुमच्या मॅट्रिक्स ऑफ टी विथ रिस्पेक्ट टू बीटा. ओके, एखाद्या ट्रान्सफॉर्मेशन बद्दल जेव्हा आपण माहिती सांगतोय तेव्हा काय सांगतोय आपण? त्या जो काही मॅट्रिक असेल, ओके, दिस इज टी इज द ट्रान्सफॉर्मेशन लिनियर ऑपरेटर. देन if A is the matrix of T with respect to that standard ordered basis beta, ह्याच्या eigenvalues म्हणजे याच्या eigenvalues. हा नॉन सिंग्युलर असेल तर हा नॉन सिंग्युलर, हा सिंग्युलर मॅट्रिक्स ऑफ हा ए सिंग्युलर असेल तर हा ट्रान्सफॉर्मेशन सिंग्युलर. ओके, हा जर 1 1 असेल तर हा पण 1. हा मॅट्रिक्स जर इन्व्हर्टिबल असेल तर हा ट्रान्सफॉर्मेशन पण याचा इन्व्हर्स एक्झिस्ट. ओके, सगळ्या प्रॉपर्टीज हा सिमिलर पॅरलल जातात. ओके, वेट. The next definition: singular and non-singular. Non-singular transformation. Okay, let T be a linear transformation. Okay, not operator now here. Let T be a linear transformation from vector space V over F into W over F. म्हणजे तुमचा डोमिनंट कोडोमिनंट डिफरंट. Then T is said to be non-singular. Okay, if the null space, the null space of T, that is kernel of T. Okay, null space is nothing but kernel of T. Consist consist of zero vector alone. Okay, what is the meaning of this one? Let T be the linear transformation from vector space V over F to V over F to what? Linear transformation from W over F. Then if T is said to be a non-singular, if the null space of T, that is kernel of T, that is equal to what? Null space of T is equal to consist only zero vector alone. म्हणजे हा एकटाच असायला हवा singleton zero. That is if alpha belongs to V and T of alpha is equal to zero. It implies alpha must be is equal to zero. Okay. Okay. Is it right? Then that T is called as now transformation. Okay. Any doubt?
No,
No,
sir.
sir.
This one is V over F. Okay. This one is W over F. Okay. Suppose this is alpha. आज T of 0 to 0 ला मॅप होतोय पण हा जर हा इथला ट्रान्सफर होत असेल T of alpha is equal to 0, then this alpha must be equal to 0. Okay, that is the kernel of T, that is null space of T contains only zero vector. Then this implies T is non-singular. That means T is 1, 1. Okay. आज 0 to 0 ला कन्वर्ट होतोय, ट्रान्सफॉर्म होतोय. जर हा सुद्धा अल्फा जर ह्या 0 ला ट्रान्सफॉर्म होत असेल तर तो 1 असेल का? नो. ओके. 1 नाहीये ना, हा मिनिमम फंक्शन आहे, मिनिमम ट्रान्सफॉर्मेशन. If kernel of T is equal to 0, that is this implies T is non-singular. Implied and implied असतात ना हे स्टेटमेंट. If T is 1, 1, then kernel of T is equal to singleton 0. Okay. If there exists a non-zero, there exists a non-zero vector alpha belongs to capital V such that T of alpha is equal to 0. Then T is said to be singular. Okay. Any doubt? Okay. Let's try
No,
theorem
sir.
3 miles over there. We will see in the next lecture. Okay. For today. In notes, I have to notes. Okay. What is a singular? If kernel of T is equal to singleton 0, null space of T is equal to singleton 0, that means there does not exist any alpha belongs to V such that T of alpha is equal to 0. Okay. There does not exist any non-zero vector. असा कोणताही non-zero vector exist होत नाही जो की T of alpha is equal to 0. जर तो झाला तर काय असेल? Alpha is equal to 0. Okay, if there exists a non-zero vector, consider such that T of alpha is equal to 0, then T is said to be a singular. Okay, now some notes are there. Get first note. First one, a linear transformation T from V into W. Okay, vector space V into vector space W is non-singular. Non-singular. If can only if. Okay, obviously just not check that. He is 1, 1. Okay. Second, a linear transformation P from V into capital W is non-singular. Non-singular. If and only if. Okay, pahal खूप महत्वाचं आहे. T carries each linearly independent subset, okay, not subset, subset of V onto a linear independent subset of W. Okay, what is the meaning of this one? If suppose T is non-singular, that is T of alpha is equal to 0 if and only if alpha is equal to 0. Okay, that means that is what? 1, 1. Okay, and suppose this one is vector space B over F. This one is vector space W over F. Okay, and this is suppose this subset yes. Yes is linearly independent subset of V. Okay, suppose alpha 1, alpha 2, alpha 3 असे काहीतरी vectors आहेत. Alpha 1, alpha 2, up to 1, alpha n. Okay, these are the vectors in S. Then this is T of S. Okay, T of S contains T of alpha 1 up to 1, T of alpha m. Okay, if S is linearly independent and T is 1, 1, then this T of is also linearly independent. Okay? Any doubt? That is non-singular.
No, sir.
Okay, if and only if subset दिला तुम्हाला if and only. मग काही वेळेस काय करतात? T carries each linearly independent subset of V into linearly independent subset of W. Then T is 1, 1, T is 1, 2, T is invertible. None of these. Okay, so what? Linearly independent subset transform to linearly independent subset of our codon. Then T must be 1, 1, non-singular. 1 of is equal to single. Okay? It is independent असेल हा सेट हा जर T of is इथे काय असेल हा independent असेल असतोच. Okay, and third note is a linear transformation on a finite dimensional vector space is invertible. Okay, if and only if T is non-singular. एखाद्या matrix जर non-singular असेल, suppose one matrix, any one of matrix is non-singular, that is determinant of A is not equal to 0. We can write. Okay, then we can say that this A inverse exists. आपण म्हणतो. Suppose here what? This one is V over here. This is the transformation T. Okay, this is W over F. And this one is T inverse. Okay. Now what we have? T is non-singular. Non-singular means T is 1, 1. Okay. 1 to 1 correspondence. Suppose ह्याची dimension आहे M. Okay. ह्याची dimension N. We don't know what is the relation between M and N. But we know that T is 1, 1. इथला हा एक एलिमेंट इकडच्या एकालाच करस्पॉन्ड असतो. इथे हा एक, इथे हा एक. ओके, असे प्रत्येक एलिमेंट कुठेतरी हा एकाला करस्पॉन्ड असतो. ओके, आय डोंट नो द फंक्शन इज वन टू ऑन टू ऑर नॉट, म्हणजे इथे काही एलिमेंट असू शकत नसू शकत. देन वी कॅन डिफाइन T inverse from W over F to V over F. Okay, that is linear transformation on finite dimensional vector space is invertible. Inverse is super. Then if and only if T is non-singular. And if T is non-singular thing, then linear transformation is invertible. Okay, suppose हा तुमचा वन नाही आहे, हा आपण इथे मॅप होतोय, इकडचा मॅप हा ह्यालाच मॅप आहे. समजा टू एलिमेंट्स मॅप टू द सेम एलिमेंट ऑफ W. हा काय फंक्शन, मेन इव्हन फंक्शन. ओके, इथून इथे असताना इथून इथे जाताना काय होईल, वन मेन फंक्शन होईल ना. इज इट करेक्ट? पण एखाद्या इमेजला हा तुमचा डब्ल्यू,
Yes, sir.
दिस वन इज डब्ल्यू, हा टी इनवर्स, सपोज दिस इज टी, इकडून इथे काय होईल टी इनवर्स, दिस वन इज व्ही. ओके, इकडचे दोन एलिमेंट काय होतील, इकडच्या एकालाच करस्पॉन्ड होते, युनिक इमेज. सॉरी, एकच मिनिट चुकलं. इकडचा एक एलिमेंट दोन इमेज येतील ना. सपोज दिस इज डब्ल्यू अँड दिस वन इज पी, दिस वन इज टी इनवर्स. असा येईल ना. एका पॉइंटला काय, each and every element of W we have unique image, but here we get two distinct images. So this is not function. Transformation ची गोष्टच लाभ, functions नाही येतो. Okay, that's why for the invertible we must have T is non-singular. Any doubt? वन मेनी हा फंक्शन होत नाही बरं का.
No, sir.
एका पॉइंटला एकच युनिक इमेज इन कोड पाहिजे, तुमचा इथे युनिक इमेज नाहीच इथे. दॅट्स वाय दिस टी इनवर्स इज नॉट फंक्शन, म्हणजे फंक्शनच नाही तर ट्रान्सफॉर्मेशनची लांबचीच गोष्ट. ओके, सो फॉर द इन्व्हर्टिबल वी मस्ट हॅव टी इज नॉन सिंग्युलर. ओके, एनी डाउट अप टू हियर?
No, sir.
Okay, so for today it is sufficient. Wait a minute.